Hi, this instruction video is a continuation of combinations. And we're going to use the combinations method to find the total number of possible ways you could have a 5-card hand. Keep in mind that in a deck of cards, there are 52 total cards. Inside a 52 deck of cards, there are 13 different type of cards, starting from ace, the 2, 3, all the way to 10, and then the face cards, which are jack, queen, and king. There are also 4 suits, which are, well, the spades, the hearts, the clubs, and the diamonds. Okay? Keep that in mind. Some of you, I'm sure you're a gambler, so you should know what they are. So keeping that information aside, when they say, if you were given a 5 cards, what are the total possible ways you could have a 5 face cards? Well, if you noticed, the jack, queen, and king, each of those face card jack, for example, has 4 suits. So that's 3 times 4. There are a total of 12 different face cards. So it's basically a combination of 12 cards, choose 5. And the way we have to set up the factorial is the 12 factorial over the 12 minus the 5 factorial times the 5 factorial. So 12 minus 5 is 7. So this is like saying 12, 11, 10, 9, 8. And I'm not going to do 7. Well, let's just write the whole thing out. 7, 6, 5, 4, 3, 2, and 1. All over 12 minus 5 is 7. 6, 5, 4, 3, 2, 1. Times the 5 factorial, which is 5, 4, 3, 2, 1. And the reason why I was reluctant about writing the 7 up here is because the 7, 6, 5, 4, 3, 2, 1 cancels out the same on the top. Now we have to find the factor and reduce all the factors in the 5 factorial from the top. So for example, 5 times 2 is 10. Those two knock out the 10 from the top. The 4 and the 3 is 12, so it knocks out the 12 from the top as well. So all you have remaining is then 11 times 9, which is 99, times the 8. And 99 times 8 is, let's see, 72, 72, 79. So there are 792 possible ways of holding up 5-card hands, and you're going to have it as a face cards only. So that's the way. Now, how about number 2 and 3? See if you can make sense out of those two. Alright, now, this was a little tricky. You're thinking that there are 52 cards total, and you're trying to figure out, or pulling out 4 sevens. So you're thinking probably out of 52, choose 4. But no, it's a lot more straightforward than that. Anytime you're taking a test or doing homework and the question is asking you for specifically sevens, well, there are 4 sevens in a deck of cards. So what that becomes is, in fact, the combination of 4 sevens available, choosing 4. And there's only one way to do that. Some kids mistaken probability with the possible hands being held when you're having a deck of cards. And one other card, well, check this out. If you did choose 4 sevens out of a deck of cards, there's 52 deck cards in a deck, and you chose out 4, wouldn't there be only 48 remaining? And if you pull 1 out of that 48, that's like saying the combination of 48, choose 1. And you multiply the 2. Anytime they say, and, you're going to multiply the 2 possible combinations. So 4 choose 4, that's 1. Because, well, it's like this. 4 factorial over 4 minus 4 factorial times 4 factorial. 4 factorial is, well, 4, 3, 2, 1, 4, 3, 2, 1. Those get canceled out. It's just simply a 1. 4 minus 4 is a 0. By definition, 0 factorial is still 1. All that mumbo jumbo basically means if you have a same 4 available, choose 4, it will always become a 1. times 48 choose 1. There's just 48 possible ways. So the answer for this one is 48. And number 3? Again, this was a little tricky. How many total ace cards are there in the deck of cards? 4. So out of that 4, you're choosing 1 ace card out. And now it says 4 other cards, which means you don't want to pull out another ace. So again, you have to pull out 3 other aces out of the deck. So 1 ace pulled and 3 ace cards pulled out, because you don't want it anymore. There's only 48 available. So it's another combination of 48 choose, this time 4. You don't care what cards they are, as long as they're not ace. And so 4 choose 1 is going to be just 4. 48 choose 4. Let me use a calculator for that guy. 48, combination of 48 choose 4. We get 194,580. So 194,580. And if you multiply that times the 4, the total possible number of ways of holding this card is 778,320 possible ways of holding a 5-card hands, where you will have 1 ace and 4 whatever non-ace cards. So there you have it.